Okay, now we're going to take a look at transforming coordinates, whether they be a list of coordinates of ordered pairs, possibly in a table form, a list form, or even the graph itself. Maybe it's just a graph of a general function. So for the x-coordinates, to know what our new x-coordinates are going to be after we apply our transformations, we're going to set what's inside the parentheses, inside that function notation parentheses, equal to each x-coordinate and solve. So remember, x is anything that involves any kind of horizontal stretches, compressions, left or right shifts, or reflections across the y-axis. It's always opposite of what you think, and that's where solving equations in algebra, previous algebra courses, then they had to do the opposite to both sides. That's what's going on. It's this shifting or reflecting across the y or horizontal stretch or compression. So we're just going to take what's inside the function notation parentheses, set them equal to each x-coordinate, and solve. Now for the y-coordinates, where the y-coordinates follow the way like a vertical shift does go up for a plus and down for a minus, we're just going to replace the f of parentheses part with each y-coordinate and then just evaluate, which we can do easily with any calculator. All right, so for this example, we have a table of values below. We're going to determine the coordinates after each transformation. So we have the ordered pairs -3, 2, 0, -5, 8, and 0. And so we want to apply this transformation of -3 times f of -2x plus 5 and then plus 1. So we can start with the x-coordinates, and all we have to do is we take this -2x plus 5 in parentheses here, and we set it equal to each x-coordinate. So -2x plus 5 equals -3, -2x plus 5 equals 0, -2x plus 5 equals 8. If we solve the first one, we get x equals 4. If we solve the second one here, we get x is 5/2 or 2.5. And if we solve the third one, we get x is 3/2 or 1.5. So these are going to be the new x-coordinates after we apply this transformation inside the function notation. For the y-coordinates, we can replace this -2x plus 5 with each output value. So for our first y-coordinate of 2, we're going to take -3 times 2 plus 1. For our second y-coordinate, -5, we're going to take -3 times -5 plus 1. And for our third y-coordinate of 0, we're going to take -3 times 0 plus 1. So for our first one, we get -3 times 2 plus 1 is -5. For our second one, we get 16. And for our third one, we get 1. So these are going to be the new y-coordinates for their respective x-coordinates. And so putting it all together, this function will transform and give us the following values. So we had 4, -5, 5/2, 16, and 3/2, 1. So these are our new ordered pairs after the transformation of these points. So maybe these points are given in a graph. Well, you can just list them out as a table or list them out as 3 ordered pairs. So you can work with those how you like. All right, so now let's try this new transformation, 4/5 times f of 2/3 x minus 3, and then a minus 3. So once again, we're going to take the inside the parentheses 2/3 x minus 3, set it equal to each x-coordinate. So set it equal to -3, set it equal to 0, set it equal to 8. And if we solve each one, for the first one, we get x is 0. So for the second one, we get x is 9/2, and for the third one, we get x is 33/2. Now for these y-coordinates of 2, -5, and 0, we're going to take our f of 2/3 x minus 3 part and just recognize that is just the outputs of the y-coordinates. So we take 4/5 times each y-coordinate minus 3, so 4/5 times 2, 4/5 times -5, and 4/5 times 0, and also minus 3 for each of those. For the first one, we get -7/5, -7 for the second, and -3 for the third. So we've taken these ordered pairs, this table of ordered pairs, and we've transformed it into these new ordered pairs. So again, whether you have them in list form as x and y coordinates, maybe they're in table form, or even a graph, you can list out the coordinates, the key points of the graph. You can transform those points, hopefully fairly simply.